Hello, a very good morning to all of you. So we are going to continue with a brand new chapter for organic chemistry semester 3, where we are going to continue with hydroxyl compound. Okay, so as usual, we are going to start with the objective question. So before we begin, if you like my video, please help me to click a like. And if you want to receive more latest information about my slide, do subscribe to my channel. Okay, so without hesitation, let's begin. Let's have a look at the question for objective question, starting from number 1. Which of the following compound will give you a precipitate of iodomethane when react with iodine and aqueous sodium hydroxide? So for the case of alcohol, you will require what we so-called as a methyl alcohol group. Okay, so a methyl alcohol group is made of what we so-called as a OHCH-CH3. Okay, so among here, A don't have, B don't have, only C have, which is ethanol, okay, and D also don't have. So that is why the best answer for number 1 is C. Number 2, which of the following reagent can react with both ethanol and phenol? So for ethanoic acid, so ethanoic acid can only react with ethanol, but for phenol, it still can react. However, it is not the best substance to react with. So we do not consider A as the best answer. As for B, aqueous bromine, ethanol cannot react with bromine, but phenol can. C, ethanoyl chloride. So ethanoyl chloride can react with both ethanol and phenol. And compared to ethanoic acid, ethanoyl chloride is better when react with phenol compared to with ethanoic acid. And finally, aqueous sodium hydroxide. Ethanol cannot react with sodium hydroxide, but phenol can react with sodium hydroxide. Okay, so that is why the best answer for this question number 2 is also C. As for question number 3, a solid compound X readily dissolve in water to give a weak acidic solution. On evaporation of water, X will recover unchanged. Which of the following could be X? So in here, amino acid is actually a weak acid and it dissolves in water to form a deuterion, and when vaporized back, it will form back the ethanoic acid. So the best answer in here will be donkey D. Which one of the following is a product of a reaction between phenylmethanol and ethanol chloride? So you have phenylmethanol, CCH5CH2OH, and ethanol chloride. So the ethanol chloride will make up of CH2CO, whereas the phenol will make up of the CCH5CH2. So the correct formula will be CCH5CH2OC double bond OCH3. So in here, as you can see, the best answer in here is donkey D. Okay, now the way of this is actually a way of how we write reversely the ester. Okay, number 5, which of the following statements about phenol are incorrect? Number 1, phenol react with ethyl chloride to form ethyl benzoate, which is correct. Okay, and phenol react with hydrogen chloride to form chlorobenzene, which is cannot. Phenol cannot react with hydrogen chloride. However, ethanol can. Ethanol can react with hydrogen chloride catalyzed by zinc chloride to form back chloroethane. Okay. As for number 3, phenol react with aqueous sodium hydroxide to give a phenoxide salt, which is also true. Okay. Oh, we are looking for incorrect. Oh, sorry. Okay, so going to reverse back again. Sorry. Phenol react with ethanol chloride to form ethyl benzoate, which is not true. Sorry. Because it will form what we so-called as a phenyl ethanoate, not ethyl benzoate. So number 2, phenol cannot react with hydrogen chloride, as we mentioned just now. Number 3, phenol can react with sodium hydroxide to give a phenoxide salt, which is true. So 3 is not in our answer. And then number 4, phenol can oxidize to carboxylic acid, which is not true because phenol can no longer be further oxidized by any oxidizing agent. So the best answer in here is 1, 2, and 4, B. Number 6, chloroethane can be formed from bromoethane in 2-step reaction X and Y. Which statement about these steps are correct? Number 1, step X including nucleophilic substitution reaction, which is true. It is a nucleophilic substitution reaction. And then number 2, hot aqueous sodium hydroxide is the reagent of X, which is correct. Okay, so you react with sodium hydroxide under reflux to form alcohol. Hot sodium, aqueous sodium hydrochloride is the reagent in Y, which is not true because Y either you use a thionyl chloride or phosphorus pentachloride, and white film is observed as a side product after ethanol react with Y, which is true. Okay, so the best answer in here is 1, 2, and 4, also B. Then we continue with number 7. Which of the following is the strongest base? So in order to produce the strongest base, you must have the weakest acid. And among the weakest acid, if you compare between phenol and also alkyl alcohol, phenol is a stronger acid compared to alkyl alcohol. So C and D is already out from our choice. So A and B. So the longer the alkyl chain, the greater the electron donating effect, therefore weaker the acid. Okay, and therefore weaker the acid, hence stronger the conjugate base. So the best answer in here would be A. Number 8, resveratrol is an insect repellent which is emitted by damaged plant. Which reagent in its reaction with resveratrol show both electrophilic addition and electrophilic substitution reaction? So in here, you can react with the C double bond C in here to undergo electrophilic addition, and you can react with the phenol part or the here to form electrophilic substitution reaction. So let's have a look one by one. So starting from A, bromine. So bromine can react with C double bond C, yes, and can also react with phenol. Okay, so A is the best answer. Okay, then B, ethanol chloride. Ethanol chloride can also only react with the phenol here, but not the C double bond C. Hydrogen bromide. Hydrogen bromide can only react with C double bond C, but not the phenol part. And finally, D, steam. Steam is water. So what steam can only react with the C double bond C, but not the phenol compound. Okay, so the best answer in here is A. Number 9, phenol was one of the earliest antiseptic used. However, it caused a painful blister on the skin. A safer and more effective germicide can produce by reacting phenol with aqueous chlorine, which is the formula of this safer germicide. So similar to bromine, when phenol react with chlorine, it will produce, because OH, phenol is a very strong ring activator, so it will cause all the chlorine to substitute at auto and para position. So therefore, the best compound to form after reacting with chlorine is 2,4,6-trichlorophenol. Okay, so the answer is C. Number 10, which of the following could be a correct synthesis of aspirin? So aspirin contains benzoic acid and also an ester as the functioning group. So let's have a look one by one, A, B, C, D, on whether it is the best way to prepare or not. Starting from A. So when A, this is the ester part, when react with sodium hydroxide under reflux. Now, for the first part, this is correct. However, for the second part, this is wrong because this carboxylic acid can, this ester can also be hydrolyzed with sodium hydroxide. So A is already wrong. As for B, ethanol chloride. Ethanol chloride cannot react with carboxylic acid, which is true, but can react with phenol, which is also true. So the best way to synthesize this aspirin can use the process number B. As for C, when you react with ethanol, both of them will form the ester, however, not the desired aspirin. Even if ester is produced, so the ester form is COO, CH2CH3. So C is not true. And finally, for D, when you react with sodium hydroxide, similar to the situations in A, both cyanide and also ester will undergo alkaline hydrolysis to produce COO and A. And in here, it does not react. Therefore, it is incorrect to synthesize aspirin using these methods. So 10 is B. Number 11, an aqueous compound X has the following properties. Compound X and compound Y react to form ester. Okay, so let's hold on to that first. Compound X react with sodium to give hydrogen. So this gives us the idea that X may be alcohol or carboxylic acid, and X gives yellow color on alkaline iodine solution. So compound X could be what? So A, propanol. Can propanol used to react to form ester? Cannot. So A is out from our choice. B, propan 1O. So you can form to react with another compound to form ester, correct? You also react with sodium hydroxide and sodium to give hydrogen, also correct. However, it does not give yellow color to alkali iodine solution because it does not have this L-methyl alcohol group. Okay, CHOHCH3 group, so it don't have. So number B is also wrong. As for C, butan 2O, yes, it can react with another compound to form ester. It can also react with sodium to give hydrogen since it contains hydroxyl group. And X gives yellow precipitate of alkali iodine solution, which is correct because of the methyl alcohol group present in butan 2O. So that is why it is able to give the reaction. So the best answer so far in here is C. As for propanoic acid, so propanoic acid can react with alcohol to form ester. It fulfills the first requirement. Second requirement, react with sodium hydroxide to give hydrogen, which is also correct. And X give yellow precipitate, which is not correct because carboxylic acid cannot react with alkaline iodine solution. So the best answer in here is C. Number 12, which of the following compound can be used to produce the following structural formula? So this is a tertiary alcohol, 2-phenyl butan 2O. Okay, so this is definitely must using a Grignard reagent to synthesize tertiary alcohol. And as what we have learned previously, so to synthesize a tertiary alcohol, you will require a ketone react with a Grignard reagent. So automatically in here, number 3 is already out from our choice. So B and C is already wrong. So 1 is guaranteed correct. So what about number 4? Is it correct? So number 4, when you attach the phenyl rings to here, it seems that number 4 can also react to form this compound. Okay, so the best answer in here is 1 and 4 only. Okay. Okay, so this is for number 12. Then we go to number 13. The scheme below shows the formation of compound Z from propan 2O. So this is the reaction scheme. Which of the following could be X, Y, Z? Okay, so in here, I also illustrated the diagram for you so that you can see clearly what happened to each of the reagent and condition used. So you use PCl5 SOCl2 to synthesize the required haloalkane. Then haloalkane, you react with magnesium to form a Grignard reagent. And Grignard reagent react with ketone under acidic condition to form a tertiary alcohol. So as you can see in here, the best answer that describes the correct scheme flow in here will be B. C would be C. Yeah, sorry, my mistake. It's C, not B. Okay. Pardon me for that. Okay, so that is for question number 13. As for 14, when an organic compound X was treated with phosphorus pentachloride, fumed hydrogen chloride will evolve. When X warmed with acidified potassium dichromate, the solution turns green. Which of the following could be X? So the first statement that says that can react with the phosphorus pentachloride means that this compound must have an OH functioning group. So it can be alcohol, it can be carboxylic acid. So A and B is accepted, C and D is not. Okay, then it can further react with aqueous potassium dichromate, which is an oxidizing agent. So carboxylic acid, except from metanoic acid, can no longer further oxidize, therefore cannot react. So the best answer in here will be A. Number 15, a reagent that can be used to convert ROH to become RCl, it is either phosphorus pentachloride or thionyl chloride. Okay, so the best answer in here is donkey D. Number 16, when substituent E is substituting hydrogen from phenol, acidity of the phenol will increase. E may be 1. So in order to increase the acidity of phenol, you must have an electron withdrawing group. Okay, electron withdrawing group. So among them, which one is an electron withdrawing group? We shall have NO2, Cl, and also COOH. Okay, so these are the compounds which will increase the acidity of the organic substance. Therefore, the best answer in here is B, 1, 2, and 4. Then straight away we go to number 17. Compound X is an optically active alcohol that gives a positive response to iodine test. So let's have a look from the first statement, which one is already out from our choice. A is correct. because it's optical active and give a positive iodine due to the this methyl alcohol group. As for B is incorrect. Correct, because you does have a optical carbon atom. However, it does not give a positive test to iodoform test. So B is wrong. And then for C, it is optically active, yes, and it gives a positive test to the iodoform test because of the methyl alcohol. So C is also correct. Last but not least, D, because you have a primary alcohol, which is impossible to react with iodoform test. So D is automatically wrong. So let's have a look at which one is the determining. Yeah? So when react with hot acidified potassium manganate, the product form is neither optically active nor react with the positive to form iodoform test. So in here, it seems that after undergo oxidation, it does not give a positive test to iodoform. So for A, which is a secondary alcohol, when you further oxidize, you still become butanone. So butanone can still give a positive test to methyl alcohol. But in here, they said they don't want to form a positive test to the iodoform test. So therefore, you will not have the methyl carbonyl group. So in here, C would be the best answer. Why? Because when C oxidizes, it will become benzoic acid. Then we go to question number 18. Iodoethane can be prepared for the reactions between iodine with ethanol with. Number one, is it iodine? Not correct. Is it phosphorus? Triiodide, which is maybe correct. Solution of sodium iodide, which is incorrect. And potassium iodide, which is also incorrect. So the best one in here is still boy B. Then we have number 19. In chemical industry, phenol is produced by either cumene process or the hydrolysis of the chlorobenzene diol process. What are the advantages that the cumene process has over diol process? So the use of in is expensive material, which is correct because the synthesis phenol via cumene process, you only require aromatic compound, benzene, and also propene, which can be obtained easily from the fractional distillations of the this crude oil. Okay, and then so one is correct. Number two, the useful byproduct, which is also correct because the byproduct other than phenol, you will also produce propanone, which is often very popular in the synthesis of propanone. Okay, so propanone is popular in the cosmetic. Okay, in pharmaceutical is also important because they can use as a solvent. Number three, the product of the highest has a higher purity of phenol, which is incorrect. Okay, so it doesn't mean that when it is suitable, it can produce a high purity. And number four, procedure of preparing phenol is less complicated, which is not true also because it involves at least 3 steps to synthesize phenol. So it is not practical to synthesize phenol under such condition. So therefore, the best answer will be 1 and 2 only. Okay, donkey D. Number 20, the cleavage of C-double-bond-O in ethanol involved in the specific reagent and reaction condition. Which of the following reaction and reaction condition involve the CO cleavage in ethanol? So this is the tables that I shows you which reactions are fission caused by CO and H, and then which reaction caused by fission of OH. So it seems that the one which is reacting is excess concentrated sodium sulfuric acid, which is for dehydration. And then last but not least is the concentrated HCl in ZnCl2, which is for chlorination. Okay, the rest it does not. So the best answer here is 2 and 3. Then we have 21. Which of the following reaction produce ethanol in the lowest concentration? So usually an industrial process with the most manual methods will usually yield a low percentage of alcohol, and it seems that glucose in yeast under anaerobic condition will usually yield the lowest percentage of the alcohol involved. Okay. 22. A compound has the following chemical properties. Number one, it gives a positive test to iodoform test. So let's have a look at the selection ABCD, which one is out from our answer already. So it seems that A have because A can, because A have methyl alcohol. B also can because it have methyl carbonyl. C cannot because you will have methyl alcohol. Tertiary alcohol can never give a positive test to iodoform test. Okay, so C is also wrong. And finally for D, D is you do not have this methyl alcohol group, so D also wrong. So the answer is either A or B. Okay, number 2, it decolorized aqueous potassium manganate. So it seems that only ethyl alcohol can, but not this carbonyl compound. So A is better answer. And finally, it reacts with phosphorus pentachloride, which further confirm that A is the best answer for this question number 22 because it can react with all the 3 species shown below. Okay. Then we have question number 23. 2-chloro, 2-methylbutane, 1-chlorobutane are separately reacted with the potassium hydroxide. The reagent can be used to distinguish the product of the reactions is in here, when you react with potassium hydroxide, 2-chloro, 2-methylbutane will form a tertiary alcohol, while 1-chlorobutane will form a primary alcohol. So when it is used for primary alcohol, so primary alcohol has more usage compared to tertiary alcohol. So the best answer in here will be the PD. Number 24, when CCH5OH phenol, and then you have Cl6H4OH, and then you have CH3CCH4OH, react separately with sodium hydroxide, basic sodium salt are formed. Which of the following group is arranged in the ascending order of basicity? So when you are now talking about basicity, you must be talking about which of the substance is the most acidic to the least acidic. Okay, so starting from in between these 3, the weakest acid will be a methyl phenol. Okay, so 22, the CH3CCH4OH, C6, correct, CH3CCH4 is the weakest acid, followed by phenol itself, CCH5OH, and the strongest acid is chlorophenol, Cl6H4OH. Okay, so now we are not ascending order of acidity. We are now ascending order of basicity. So weakest acid will produce the strongest base. So the weakest base starts from the CH3, CCH4OH. Sorry, Cl first. Cl, CCH4OH, which is the weakest base, strongest base is ClCCH4OH, then followed by phenol, and then the weakest acid will be CH3, CH3CCH4OH is the weakest acid. So in terms of conjugate base, so CH3CCH4OH methylphenol is the strongest base, followed by phenol itself, and then chlorophenol is the weakest base because it is the strongest acid. Okay, so the best answer in here will be C. Okay, and hydroxyl compounds has the following property. Number 1, it is optically active. Let's check and have a look which one is optically inactive. A and also A only, yeah. So A is already out for our choice. And then number 2, it undergo dehydration to form a compound without isomer. Okay, so B can undergo dehydration, C can also undergo dehydration, D can also undergo dehydration. But the question said without isomer. Okay, so without isomer, that even stereoisomerism cannot be considered. But in here, it seems that D can produce this stereoisomer. Okay, stereoisomer. So that is why D is already out for our choice. And then number 3, it forms a yellow precipitate when heated with alkali iodine solution. So only this B contain methyl alcohol group, while C don't have. So the best answer in here will be B. B. Let's see. B. Sorry for the mistake. Because C, because they said without isomer. Without isomer means that no isomer. B can still have geometrical isomer. Okay, my mistake. Sorry for that. Okay, then number 26, which of the following methyl lithium will produce 2-methyl-butanol? So you require a tertiary, this Grignard reagent react with ketone to give a tertiary alcohol. So the best answer here is not B. Number 27, molecular structure of 3 organic compounds are given below. You have B, butan-1-O, you have Q, butanol, R, this carboxylic acid. Which of the following sequence shows the order of decreasing boiling point? Of course, carboxylic acid will have the highest boiling point among all of them. So R is the first one, then followed by alcohol, which is the second one, then carbonyl compound, which is the third one. So the one which correctly arranged is B. Number 28, which pair of the compound corresponds to the reagent used to differentiate between the two compounds? So A, sodium metal. Can sodium metals react with both compounds, which is yes. So because they both contain OH. Okay. And then B, what about bromine water? So alkyl alcohol cannot react with bromine water, but phenol can. So B seems like one of the best answers so far. And then C, phosphorus pentachloride. So both alcohol and the carboxylic acid can react with the phosphorus pentachloride. So C is correct. And then finally D, CCH5OH and CH3COH. So can you use sodium hydroxide, which is also can, because cannot, because both phenol and also ethanoic acid can react with sodium hydroxide. Okay, so the best answer in here is still B. 29, pentaethyletol is the intermediate used to manufacture paint and has a structural formula below. So which of the following is true? Number 1, its monomer can form a cross-linked polymer, which is yes, correct. Number 2, it reacts with thionyl chloride, which is also correct because you have 4 OH group. And then number 3, it can dehydrate to an alkene, which is incorrect because there is no neighboring hydrogen. And then number 4, it can be oxidized by hot acidified potassium manganate, which is also true. So the best answer is 1, 2, and 4B. And finally, number 30, an organic compound acts with the molecular formula C6H11Cl is converted to compound Z by the following reaction scheme. So first, you react C5H11 with NaOH, okay, under reflux. So this is in order for you to form alcohol. Then alcohol will further oxidize to form Y, CKMnO4, form Z, which of the following Z can form an orange precipitate with 2,4-dinitrophenol hydrazide. So you must bear in mind that after oxidation, which one can still give an orange precipitate? So it is either aldehyde or ketone. Okay, so your answer of X, Y, Z must be synchronized in order to get the correct answer. So let's start from A, B, C, D. So it seems that when A, C5H11Cl react with sodium hydroxide to give a primary alcohol, then you give aldehyde, which is incorrect. You're supposed to give carboxylic acid. So A is wrong. And then B, you have 3-chloropentane, which is maybe correct. Then 3-phenol, which is correct. However, for the last one, when you oxidize, it will not become ester. It will still become carbonyl compound because it is a secondary alcohol. As for C, CH3, CHCl, CH2, CH3 can react with sodium hydroxide to form the alcohol, secondary alcohol. Then this secondary alcohol is the Y shown in the diagram. And the last one, when react with this oxidizing agent, ester cannot. Okay. So the so far the answer in here will be C. No answer, huh? No answer because the product of the C is a ketone. Oh yeah, correct, ketone. Okay, correct. C is the answer, and then as for D, tertiary alcohol, D will yield a tertiary alcohol for Y, and then tertiary alcohol cannot further oxidize. Okay, so that is why D cannot be correct. Okay. Okay, so with that, that is all for how you answer the objective questions. So hopes that my video helps you to understand better of how to answer the objective. So I guess I'll see you all in our next lesson, which is about structure for this chapter. Okay, so see you all in our next lesson. Goodbye.